I want to go ahead and look at a couple problems from section 4.1. I'll go ahead and call this Graphene Polynomial Functions. Now the interesting thing is, we're going to see as we go through this, like I said in class, the main steps that we're going to use to try and graph these polynomial functions are the same steps as we used when we did problems of linear inequalities of quadratic equations. In a minute, we're going to look at how to graph this function, and we'll start out with a pretty basic quadratic equation. I'm going to try and make a rough sketch of this graph. However, you're going to see in a few minutes, back in chapter 2, we took the same kind of equation and put it in the form of an inequality, and we tried to solve this inequality. And if you recall, back in chapter 2, one of the main things we did was to find the zeros, and then we created a chart, and then created a sign chart. And that's how we solved this inequality. Well, we're going to follow maybe the same steps as a way to actually graph this function. So let me actually, as a reminder, write down the steps we're going to go through to get the information to do a rough sketch of the graph. And let me just note, whenever you graph, you can always just create your XY data table. But in this case, we want to look at some key points and not rely on the XY data table, which can be useful, but oftentimes can be a bit tedious. So let me just put the steps over here briefly, and then we'll do a couple of these problems. The first step, which you may or may not have to do, is to factor. Sometimes some problems will be given to you and it will already be factored, but sometimes, for example, the problem we're going to do in just a minute, I will have to factor it. And then find the zeros of the function. And then break graph into regions. And then at that point, I can create my sign chart. And then I have what I need to hopefully make a rough sketch of the graph. Now, as we go through this, you're going to notice that steps really 1 through 4 are the same steps that we followed when we were trying to solve quadratic inequalities. All right, so this is going to look familiar. This should be familiar to what we were doing even just 3 or 4 weeks ago. So let's take our function, and first I need to factor it. If I can't factor the function, then I'm pretty much stuck. These things are always going to have to factor. Now in this case, this is a trinomial. And it should factor into x minus 3 times x plus 2. Now to find the zeros, remember to find the zeros, you set the function equal to 0, you set f of x equal to 0, and then solve that equation. So for the zeros, I'm going to solve this equation. And this one is pretty straightforward. The zeros of x are going to be 3 and minus 2. Now those are going to be the two values of x that I use for my graph to break it up into regions. So let me draw a graph here, and we'll eventually make our rough sketch. So at 3 and minus 2, I go ahead and just sort of draw my dashed line through the zeros. And when I do that, I end up with a graph with 3 regions. And now I'm going to create a sign chart. I'll go over here to the left, and I'll make my sign chart region, test point, and then I write my factors. I have 2 factors, x minus 3, x plus 2, and then overall. All right, so this should look familiar. We've done this before. So I have 3 regions. For region 1, I'll choose a test point of minus 3. For region 2, I'll choose 0. For region 3, I'll choose 4. And now I simply figure out the signs for each of the factors. For region 1, this will be minus, minus, so overall plus. Region 1, it's going to be positive. Region 2, for value of 0, negative, positive. So region 2, it's going to be negative. Region 3, it's positive, positive. Region 3 is positive. Okay, what does this tell us? Now this tells us I'm going to try and sketch in this graph, and here's what I know. First of all, these zeros, so at negative 2 and 3, when I try and draw in my graph, my line, my graph is going to go through minus 2 and 3 on the x-axis. Remember I said before, the zeros of the function are the same thing as the x-intercepts. The graph is going to go through minus 2 and 3. Now what this says is in region 1, my graph is going to totally be positive. It's going to totally be in this region right here. But then when I get to region 2, my graph is going to totally be somewhere below the x-axis because it has to be negative. But then I get back to region 3, it's positive again. So I'm going to be somehow back above the x-axis. So this thing sort of goes back and forth. Well, hopefully you begin to see now, in region 1, if it's positive, I'm going to start up here, and maybe I'll just go like this. Notice I go through the x-intercept, or the 0 minus 2, and now I'm going to keep heading down. And just for fun, I can go ahead, I'm going to make a loop down here, but I'm going to, just to see how far down it goes, just for fun, I can go and calculate the Y-intercept. The Y-intercept is when you take the original equation and set x equal to 0. The Y-intercept is actually going to be minus 6. So I know actually when this line comes down here, it's going to go through here, and then as it turns around, it goes back up through my other 0, and here's my graph of my parabola. So this is my rough sketch, and I was able to get it through my sign chart. Now let's do another problem, a little more involved, but the same principles apply. Actually, I put y. I could have started with f of x. So x cubed plus 3x squared minus 4x. All right, first thing I have to do is factor. First of all, there's a GCF, which is x. So I have x squared. Oh, you know what? I'm sorry, I'm doing the wrong problem. Well, let's just go ahead and do this one just for practice. That's okay. Let's just finish this. Okay, plus 3x minus 4. And then inside the parentheses, I have a trinomial, which factors into x plus 4 times x minus 1. So what are my zeros? If I set f of x to 0, then the zeros are going to be this first factor. In other words, what value of x would cause this whole thing to be 0? It's going to be 0, and then minus 4, and then 4. So let's go ahead. I can start out with my graph and break it up into regions, and then do my sign chart, and then fill in the graph. So let me designate, here's my 0. I know my graph's going to go through this point right here, and then here's 4. So that's another boundary. And there's minus 4. Turns out I'm going to have 4 regions in this graph. So if I can go over here and squeeze in my sign chart, I have 3 factors, x plus 4, x minus 1, and then overall. I have 4 regions. Test point for region 1, let's choose minus 5. For region 2, let's choose minus 1. For region 3, we'll choose 1. For region 4, we'll choose 5. So x, let's go region 1. I go negative, 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 overall negative. Region 1 is negative. Region 2, for negative 1, negative, positive, negative, overall positive. Region 3, positive, positive. Oops, I wrote down. Wow, I really messed up here, guys, huh? This 0 should be 1. So really, all right, that just proves, I wonder how long, you probably were wondering how long it was going to take me to catch my mistake. So let's go ahead and try and redo my graph if I have room. That was a pretty major error. I did catch it, but all right, so now one of my zeros is at the origin. Now, I do have one at negative 4. And then over here, it's at 1. So the key is, here's my 4 regions. Region 3 is pretty skinny. So region 3, I'm going to choose a test point of 1/2, because I have to be between 0 and 1, and I'll leave region 4 as 5. It doesn't really matter. So now, back to my sign chart, when I look at 1/2, positive, positive, negative. You know how I knew my point was wrong? Because when it was 1, when I was checking my signs, I realized that 1 minus 1 is 0. And I realized you cannot pick one of your boundary points to be your test point. So that gave me the clue that I had messed up with my zeros. So overall, it's negative. And then if I choose 5, positive, 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 positive. So now I have negative, positive, negative, whoops, negative, positive. So I know my graph's going to go through my zeros. So if it's negative here, it must come up. Now, I don't know how far up it's going to go. I'm just going to make an estimate. Maybe I'll say it looks like this. Then it comes down. Now I know it's negative here, but it goes back up here, so I'll just make a small sort of loop here and then go back up. Once again, this is sort of a rough sketch. I don't know about these points exactly, but this is the shape of the graph, and if you want to get more precise, you can fill in some data points. Let's do one more quick example. And this actually, from 4.1, now I'm going to do this problem in the form that they're going to give you in the homework assignment, because they ask for some specific things. My advice to you is to go ahead and just go through the steps that we have gone through and create your graph. And then once you've created that graph, you can answer all the questions they have. So here's a problem. X plus 1 times x minus 1 squared times x minus 2. So it turns out this function has already been factored. So I'm going to find the zeros. So I look at each of these factors and determine what value of x would cause each factor to be 0. My first parenthesis, x would be negative 1. The second parenthesis, x would be 1. This last parenthesis would be 2. So there are my zeros. So now I can start to create my graph. I've got 3 zeros. Here's minus 1. Here's 1. And here's 2. So I'm going to have 4 regions. So if I do my sign chart, I've got 3 factors. Notice here I have x minus 1 squared. Factors are things you multiply. So this one is not just x minus 1, it's x minus 1 squared. So if I have 4 regions, test point for region 1, I'll make negative 2. Test point for region 2, I'll make 0. For region 3, once again, it's got to be between 1 and 2. I'll go 3 halves. And region 4 is 3. And here's my overall. So then, for region 1, negative. Now it's interesting, since I square this, you know what? This thing's always got to be positive. Even though minus 2, when I plug it in for x, minus 2 minus 1 is minus 3, but when you square it, it ends up being like a positive 9. And this one's negative, so it's positive here. Region 2, positive, positive, negative. So region 2 is negative. Region 3 is positive, positive, negative. So region 3 is negative. And region 4 is positive, positive, positive. So it's interesting. I have 4 regions. I start out positive and then go negative and then negative and positive. So this graph looks something like this. You start out like this and it goes negative. And of course, it has to come like this. But instead of going positive again, it stays negative. So it's I come and it's like I touch the x-axis and I turn around and I go negative again, And then when x is 2, I cross the x-axis and I go positive. And that's how this works. As a matter of fact, something you can learn when you're graphing these, if you have one of your factors squared, that's where you get this little, where it touches the x-axis and then it turns around and goes back in the same direction. Now in your homework, just as an example, here's the kind of questions they ask you. First, they're going to ask you for the zeros. Well, we found the zeros, right? Negative 1, 1, and 2. And then in the homework, they're going to ask you for the Y-intercepts. Well, the Y-intercepts, you simply set x equal to 0 and solve for y. So if I set x equal to 0 here, I'm going to have 1 times 1 times negative 2. It looks like my y-intercept is 0 to negative 2. And actually, I didn't do too bad. If I say that's negative 2 right there. And then they say, find the domain. Well, if I look at the graph, the domain is pretty easy to see, right? Domain is what's the smallest value of x to the largest value of x. Well, in this case, pretty straightforward. And then the next part, they ask you the interval where f of x is greater than 0. In other words, what's the interval where the graph is positive? Hopefully you can see the graph. Well, it's positive in regions 1 and 4. So you simply say, I'm going to union regions 1 and 4. Region 1 is negative infinity to minus 1 union with 2 to infinity. And then they ask the same thing for where is the function negative or less than 0. And for that, I choose the negative regions. Negative 1 to 1 union with 1 to 2. Now let's talk about this. You know the negatives are from negative 1 pretty much to 2, but you know what happens? When x is 1, for that point right there, the function is not negative anymore. The function is actually 0. And this question is, when is the function negative? Well, the function is not negative when x is equal to 1. The function is actually 0. So I cannot include x minus 1. I cannot include x equal to 1 in the interval. So I have to go from minus 1 to 1, skip minus 1, and go to 2, which is what I have here. All right, so those are examples of rough sketch of graphs of polynomial functions.